And I'm going to make up some numbers. Let's say we had a ball that had a mass of 45.21 grams. Convert that to kilograms, so it's in standard metric units, so that would be 0.04521. Let's say we had an initial impact of our ball of 2.057 meters per second, and a rebound velocity 1.872. And dwell time is the contact time with the table, and that was a very small number, 0.00842. The other piece of data that you collected was the diameter of the ball, and that was 3 sig figs, so your answers should have 3 sig figs. These are just extra sig figs that are basically just calculated through the computer. They can, put as many digits as they want on the screen. All right, so you're going to calculate the force on impact and the percentage energy lost. So let me take you through a sample here. We're going to use the equation that we've been practicing this week. Change in momentum is equal to impulse. So we'll take the mass of our ball in kilograms, standard metric. Change in velocity is final minus initial. Since the initial impact velocity was going down, I'll make that one negative and this one positive. That's probably the most common mistake that kids make with this calculation, is not taking direction into account. So it's final minus initial, and that will be equal to the force on impact times the contact time, which is the dwell time on the table. So for this sample, come here, Herschel. I got a 21 Newton force. That's pretty big. I think I may have put some extra zeros in here compared to what most of you guys had. So 21.1 newtons. Okay? So that's how you calculate force. Percentage of energy lost in the collision, that's just going to be kinetic energy. And that's the final minus initial equals energy lost. And the forms of energy that get converted here are heat, sound, and deformation. Deformation probably being the biggest one, okay? The golf ball, or there was a wooden ball, are going to lose more energy due to sound, because they make a bigger sound when they hit the table. The rubber ball, a little more energy due to deformation. And you're going to not necessarily find a consistent result here, because that's going to be dependent upon how high you drop the ball. And I didn't give you like a specific height, right? Why will you lose more energy dropping the ball from a higher height?
There's more energy to lose.
Well, that's true. I should qualify my question. That's correct. Why are you going to lose a larger percentage of energy from a higher height? Right? Deforms more. That's correct. Did I show you the video of the golf ball yesterday?
Yeah.
Obviously, the one that was crazy, like completely changed its shape, kind of turned itself inside out, that was going at near the speed of sound. That was a pressurized launch of that golf ball. All right, so for this particular calculation, final kinetic energy would be 1/2 times the mass times the velocity squared. minus the initial kinetic energy notice that so energy is a scalar, so since we square the velocity, it won't matter whether it's a positive or negative velocity.
Don't the stuff cancel?
No, because if this were kinetic over here, then you'd have mass canceling, but because this is heat, sound, and deformation, it's a more general catch-all. Alex?
The other day, I think I wrote that it's kinetic energy, initial minus final.
You know what, I think it does. It doesn't really matter. This is technically the absolute value of that, so the order is not important. That's a good question. I believe I did write it like that. Okay. 1/2 m times squared equals. This is 0.0792 joules. Uh, 0.0956 joules. When I subtract those, I get 0.0164. That is the actual energy lost in joules. To find the percent, you need to do the change, the loss, divided by the initial. Okay? So energy. In this case, that'll be 0.0164 over 0.0956. And I get about 17%. 3 sig figs for all of your final answers because of the calipers. These numbers that you get for kinetic energy loss or energy loss period are going to be wildly variable. So some of you'll have 1 or 2% if you drop a ball from a very small height. Some are going to have much bigger. Yes.
I did like initial velocity squared minus final velocity squared over initial velocity squared, and I still got 17.1%.
You did this minus this over this,
No,
or the other way around?
the bigger number minus the smaller number.
Divided by the bigger number?
Yeah, but
I
all
think
of them are squared.
you squared everything. It should be fine because it's the same ratio.
Yeah.
It's
Because I wasn't actually calculating the energy, just the.
that's fine. Does anybody care to know what Ryan did? He saved himself some keystrokes. Okay. All right. Any questions about this? This is due tomorrow. And I'm going to give you some time to work in class too, Jeff.
So I dropped one of the little bouncy balls
Yeah.
way up high, and
Yeah.
I had a final velocity that was almost double the initial.
Why, that is an excellent question. I'm so glad you asked. So, if we were in the lab doing this, by the way, my son texted me last night. Guess what my physics lab partner's name is? My physics lab partner's first name. So, of course, I'm thinking, okay, it's got to be something nerdy. And he gave me a hint. His parents named him after a scientist. That was one of my guesses. I guessed Einstein, Newton, and then I just kind of lost interest. So his partner's name is Pascal. He has a younger brother named Plato. I'm thinking you're just guaranteeing that those boys are never going to date. Ever. Pascal and Plato. And Plato's just like, wear a sign that says, beat me up on the playground. Because of course, what are all the, can you imagine going to elementary school and your name is Plato? No. The famous philosopher, yeah, how do you, like when the kids start teasing you about, oh, you're named after Clay, or what, I don't know, you know. No, I'm not. It's not that, it's not Play-Doh, it's Plato. I mean, right. I just want to smack the parents. I want to go find the parents. You know, maybe because he overcame that. Wow, you are such a glass half full guy. I have learned from you today. Thank you. Okay, is anybody else with me? It's just weird. And look, I live the weird. I embrace the weird. I'm all about the weird. Okay. So you were dropping the ball at that spot, correct? And the light beam was like that. Were you perfect? Did you drop the ball exactly at that spot every single time? Absolutely not. So, did some of you notice that every once in a while you get a final rebound velocity that was actually bigger than your impact velocity? Did you get a few trials like that? Does anyone wonder why, or were you just like, that's wrong, do it again? Bad thing? Okay. So, what happens if you drop it off center? Let's say you drop it so that the light beam is right here. Does that make sense? A smaller diameter, but the computer doesn't know that. What does the computer think the diameter is? The bigger one, D. Yeah, when it calculates, what does it think? Yeah, exactly. So now, this is true science. Now what? What do you do to fix that? Average them. That would be a good first start. But really, for this truly to be a scientific process, remember you have to isolate the variables. So I don't want to be dropping these balls with all these different diameters. I want to control the diameter variable. Otherwise, I have to change it in every single trial. Exactly, and there's lots of right answers. You basically have to create a rig that controls that variable. So a tube is a great idea. Do you remember the golf ball video yesterday, like the robotic arm that had a spring and that was swinging? Why did they set up a rig to hit the golf ball? Hit it exactly the same time, yeah. So that's the real science, trying stuff, experimenting with it, getting it wrong, figuring out why it's wrong, versus the, that's bad, let's just do another trial. Just throw that out. Okay. So one of the reasons I like these labs, and even like the Red Rocket Lab, I think I probably told you this, is that when your equipment fails or when you end up with that's the real science, is trying to problem solve and figure out, okay, where is it going wrong? Like the groups that ended up with the Logger Pro boxes that weren't working, like, okay, is it the box? Is it the power plug? Did I plug the power plug in at all? Am I missing the connection cable? That's the real science. That's the good work. So I love it when it doesn't work. All right. I'm going to stop this.